Welcome to a journey through time and technology, where the pages of history reveal a marvel of innovation born amidst the turbulence of World War II. In this video, we bring to light the captivating tale of the V-2 rocket, a pioneering marvel of German engineering that catapulted humanity into the space age. Join us as we unravel the story of the V-2 rocket, a technological feat that shaped the future of rocketry and left an indelible mark on the world we live in today. Let's embark on a voyage of discovery into the heart of the V-2 rocket, an engineering marvel that changed the course of history. The V-2, with the technical name Aggregate 4, was the world's first long-range guided ballistic missile. The missile, powered by a liquid propellant rocket engine, was developed during the Second World War in Nazi Germany as a vengeance weapon and assigned to attack Allied cities as retaliation for the Allied bombings of German cities. The V-2 rocket also became the first artificial object to travel into space by crossing the Kármán line, edge of space, with the vertical launch of MW 18014 on the 20th of June 1944. More than 3,000 V-2s were launched by the Wehrmacht against Allied targets, first London and later Antwerp and Liege. The A4 used a 75% ethanol, 25% water mixture for fuel and liquid oxygen for oxidizer. The water reduced the flame temperature, acted as a coolant by turning to steam, and augmented the thrust, tended to produce a smoother burn and reduce thermal stress. The turbopump, rotating at 4,000 revolutions per minute, forced the alcohol and oxygen into the combustion chamber at 125 liters per second, where they were ignited by a spinning electrical igniter. Thrust increased from 8 tons during this preliminary stage whilst the fuel was gravity-fed, before increasing to 25 tons as the turbopump pressurized the fuel, lifting the 13.5-ton rocket. Combustion gases exited the chamber at 820 degrees Celsius and a speed of 2,000 meters per second. The V-2 was guided by 4 external rudders on the tail fins and 4 internal graphite vanes in the jet stream at the exit of the motor. These 8 control surfaces were controlled by Helmut Halser's analog computer, the Messgerät, via electrical hydraulic servomotors, based on electrical signals from the gyros. The warhead was another source of trouble. The explosive used was Amitol 6040, detonated by an electric contact fuse. Amitol had the advantage of stability, and the warhead was protected by a thick layer of glass wool, but even so it could still explode during the re-entry phase. The warhead weighed 975 kilograms and contained 910 kilograms of explosive. The warhead's percentage by weight that was explosive was 93%, a very great percentage when compared with other types of munition. The first successful test flight was on the 3rd of October 1942, reaching an altitude of 84.5 kilometers. On that day, Walter Dornberger declared in a speech at Peenemünde, "This 3rd day of October 1942 is the first of a new era in transportation, that of space travel." It was estimated that a sustained rate of 350 V-2s could be launched per week, with 100 per day at maximum effort, given sufficient supply of the rockets. During the succeeding months, about 3,172 V-2 rockets were fired at Belgium, United Kingdom, France, Netherlands, and Romania. The only effective defenses against the V-2 campaign were to destroy the launch infrastructure, expensive in terms of bomber resources and casualties, or to cause the Germans to aim at the wrong place by disinformation. The British were able to convince the Germans to direct V-1s and V-2s aimed at London to less populated areas east of the city. This was done by sending deceptive reports on the site's hit and damage caused via the German espionage network in Britain, which was secretly controlled by the British. That's all for today. See you in another video.